stop sifting through large quantities of data and actually offload that burden to AI so you can spend more time identifying patterns and trends simply via plain text asks. That's exactly what AI Query's latest capability, query analysis, allows you to do. So let's hop in the tech and show you exactly how. What's going on, everybody? Super pumped about the feature I want to break down for you briefly here today. So we already know that AI queries kind of sole predication is reducing time to context through surgically harvesting basically any data you want to answer any given question about your environment. But we want to take it one step further. So rather than just gathering the data, how do we effectively analyze and view the data in whatever form makes the most sense for your given use case? Whether that's grouping things together, identifying trends, what have you. We naturally have filters. I've done videos on that before. The dynamic filters, very valuable. But what happens if we have, this case, we have 7,000 results? What if it's 700,000, 7 million results? That's going to be a lot to try and filter down. And then we thought, well, hey, why don't we add AI-based query analysis over the results to kind of simplify that process? So that's exactly what we achieved. And if you go over to analyze right here, I actually already have one, but I'll execute this real quickly. So effectively what this is, what we're looking at is you can ask plain text questions of the data, and then AI, rather than actually running over your data for the sake of reducing time, cost, and security concern, is actually creating the database query to return the data in whatever format you want. So we're actually going to hide this. We'll just make it so plain text questions, boom, you get data, but wanted to kind of show the advanced view so you know how it's working in the background. But right here, I can immediately see I have 3 EC2 instances out there, and I wanted to correlate, okay, are we getting these brute force attempts from all the same spots, or is it totally different per each EC2 instance? And right away, we can identify, okay, there's a lot of repetition of the device IP address that is being used for these failed logins. So we have that data point. Let's say we want to go even more broad and say, show me any patterns or trends in the failed logins, and hit generate. So again, this will generate the actual SQL query, and then you can execute the query. Again, we're going to hide that and have that as an advanced mode in case you want to actually edit the SQL query itself. But again, it's you're using queries and AI to write the queries for you to extract the data in the first place. Now that you have this robust data to answer any question you want, let's ask plain text questions to be able to answer any nuance that we want within that capacity. And so that's exactly what we're seeing here. We can see immediately it's broken down by event hour, right? And so we can see here the actual time frame broken down by event hour. We can see the failed logins within that time frame. We can see the unique users associated, the unique IP addresses associated, and then a delta of change per hour. So super cool. Again, you can identify trends on large quantities of data. If I wanted to, I can actually go ahead and say, and tweak this a little bit and say patterns or trends in the user names of failed logins. I genuinely have no idea what this will generate, but I've just been having a great time messing around with this, trying to identify patterns in the data that's returned, because again, there's so much you can do with this, and this is just the first step. So wanted to kind of showcase this, and what we see here, we'll execute the SQL, and we can see here user pattern admin related because it's administrator or admin. We can see that's the vast majority of the failed logins. Again, we have 7,000, so roughly 5,000 of those are specifically targeting the what we know is on the machine, right? The administrator account. We can see the time that was first seen, unique source IP addresses, and then standard user. We can actually see the username. This is where it can get interesting too, because for instance, I could look to be like, do they have any information about me specifically, right? Are these trends of just generic fake things, or do they have to pertain to Nick or something like that? Do they have some kind of information that this is targeted, or is this a bot? And we can pretty clearly tell that it's a bot also because of the fact that the number of failed logins for each of these standard users and the attempts, 12, 12, 12, 12, and then 11, 11, 11, 10, 10, 10. So many patterns can be immediately identified when looking at it in this capacity. And just think about how much that reduces the actual time to context that you're trying to investigate a given incident. Boom, right here, you can ask a million questions and you can load prior ones for history. And then right there, you can really get to identification of the patterns of the verbose data you've been able to gather. So that's basically everything I wanted to show. I did want to point out a different workflow use case because this one's trying to identify patterns in abnormal behavior. But let's say you want to just query, this very basic query right here where I enumerate all programs. It's just select star from programs. Very simple. What's installed on these 3 devices. Again, we have a decent number of results. So we got, over 200 results. And I want to break down, I have these preloaded so you don't have to see it generate, but which applications are seen on multiple devices with different versions. So if I run that, I can see that we have a bunch of Microsoft, some Amazon because they're EC2 instances, but we can see Chrome right here sticks out to me. We can see it's on 3 devices, 2 different versions on those devices, and we can see that one version is very clearly older than the other version. So what we can do is we can go ahead and say, okay, well, let's take this one step further. So which device has the oldest version of Chrome? Obviously, it's something you could filter to, but again, if you had a ton of results, not just 3 devices, maybe it's 300, 3,000, what have you, this becomes so much easier in filtering it down that we can see, okay, it's this desktop machine, and we can see that it has this specific version of Chrome, which is older than the other ones we saw. Maybe we want to run a vulnerability query to see if this is a vulnerable version, but either way, more just want to show the point of how you can either identify patterns in abnormal behavior, looking at more instant response, trying to identify proactive trends, or you can use it purely from a hygiene capacity of trying to get broad strokes of information originally and then filter down and view it however you want to get to your end answer. So many applicabilities of this actual AI query analysis. Please let me know if you have any suggestions or use cases, but I think this is super cool and it's going to power a lot of cool things that we have coming down the pipe. So stay tuned for those. And in the meantime, check out our videos on YouTube and LinkedIn. And until next time, see ya, everybody.